Hello and welcome to today's session on Plexos for the non-expert. What we're going to try and do here is, by starting with a small everyday example, we're going to explain what Plexos does on a fundamental level. Once we've got that, we're going to add layers of complexity so that by the time we've finished in this particular scenario, there's only a small step between what we've got and what people use Plexus for on an everyday level. Our starting point is going to be a family meal. If you think about this question for a second, how many people would you have at a family meal? Is it 10, 12, 5? Up to you. Now, in my particular case, we would probably have 6. The next question is, if you were going to be making fish and chips at that family meal, how many potatoes would you need? Again, think about it for a minute, but in my case, we would probably have 12. Now let's say that you have, or that you're next to 3 different stores. In this case, we've got a farmer's market, supermarket, and organic store. And what we need to do is we need to go buy those potatoes from those stores that we have. The assumption here is that they are all the same distance away from you, and in fact, they're next door to each other. Now, if we had the prices that we've got here, so in this case, it's 10 cents per potato for the farmer's market, 15 cents per potato for the supermarket, and then 20 cents for the organic store. If these were the prices, where would you go to get those potatoes? Now, if we make the assumption that the quality is the same wherever you go, and in fact, this is a really important idea in commodities, which is that in this case, potato is a potato is a potato. It doesn't matter where you go, you're going to get the same item. Now, presumably, if we make that assumption and we see these prices, what we're going to do is we're going to go to the farmer's market and get all our potatoes from there. However, what happens if there are only 5 in stock? Again, if we also make the assumption that our main goal here is that as little money is coming out of our pockets, then what we would do is we would go get 5 from the farmer's market and then get the rest from the supermarket. We've already explained that they're the same distance away, then they're next door to each other, so that's not going to be a problem. And if we want the cheapest potatoes possible, then we need to start with the farmer's market before moving to the supermarket. However, what happens if there are only 3 in the supermarket? Well, then what we would do, again, we're trying to have as little money coming out of our pocket. So we would go get 5 from the farmer's market, 3 from the supermarket, and then whatever else we needed from the organic store. In this case, at least for our purpose, it's essentially limitless. We've put in 100, but for all intents and purposes, it's limitless, especially given that we're only looking to get 12. Using the example that I've got here, so 12, we're looking for 12 potatoes. What's our total cost going to be? Well, we can do the maths. We're going to get 5 from the farmer's market. We're going to get 3 from the supermarket, and then we need 4 to make sure that we meet the demand for potatoes from the organic store, and this total cost comes to $1.75. Now, the question that we're trying to answer, and in fact, what we've already done here, is where are we going to go to get our potatoes from? On the right-hand side, if we look at our total cost, we've got the 10 cents coming from the farmer's market, the 20 cents coming from the organic store, and then the 15 cents coming from the supermarket. And what we had to decide was how many potatoes are we going to get from each of those supermarkets, or if you like, where are we going to get our potatoes from? That both the which supermarket and how many from each supermarket can be, encompassed in the question, where are we going to get our potatoes from? And depending on those decisions that we make, depending on how many we decide to get from here or here or here, that will determine our total costs. Remembering, of course, that we're trying to have as low a cost as possible. However, that's not the whole equation, right? We're also trying to make sure that we meet, or that we have enough potatoes for the meal, right? In my particular case, I've said we need 12. So we need to make sure that the potatoes that we buy in total matches the, again, demand for potatoes, which in this case is 12. So not only do we have our total cost question up top, but we've also got to make sure that we meet, or that we buy enough for our particular meal. And then finally, we also have some limitations or bounds in this particular case. Because of the fact that they're limited stock in the various markets, we can't go and buy as many as we want from the supermarket. In fact, we have to buy less than or equal to 5 from the market, and then similarly as you work down. Now, this question of where do we get our potatoes from is actually the same question that we can answer in Plexos. And I know that you don't believe me, so we're going to have a look at this exact question in Plexos. We're going to set up our problem and see if Plexos can answer it for us. If we start here, you can see that we have our 3 stores, 3 options. Now, you might straight off the bat be wondering, well, what have these markets got to do with generators? But if you think about it, when you go to a store, for all intents and purposes, the potatoes are simply there. We don't know how they get there. They are, if you like, generated by the supermarket. So the supermarkets are, if you like, potato generators. Not only that, but they have the properties that we assigned, right? Max capacity, I think, is fairly obvious. It's the maximum capacity of each of the different supermarkets. And in this case, these are the numbers that we worked out before, namely 5 in the farmer's market, 3 in the supermarket, and then 100 for our organic store. Not only that, but we said that there was a cost to each, to each of the potatoes, there's a cost. And that's represented by what we've got here, where you can see it says VO&M charge. The VO&M stands for variable, operational, and maintenance costs. And again, we can think about the supermarkets, and they have certain running costs. They need to pay staff, they need to keep lights on, and these costs will translate into how much they charge for each potato. And just as in our setup over in our PowerPoint, we've also got the cost that you can see here. So again, it's just 10 cents per potato, then 20 cents, and then 15 cents. Finally, our region is home. And here you can see it says load, and that's another word for demand. And we've already mentioned this before, but at our family meal, we have a demand for a certain number of potatoes. And again, if we go with the particular example, then it's 12. This is now set up in Plexos. We can now run Plexos to see what results it can give. If you like, we can now hit the enter button of the calculator and see what numbers it spits out at us. And in this particular case, we go to the execute, which, as I mentioned, is like hitting the enter on the calculator button. Now, I've actually run this already, so we don't need to, but that's how you would go about it. Taking a look at some of the numbers, let's start with our various stores and where or how many potatoes we should get from each of those different stores. You'll see that Plexos is saying that we should get 5, if you like, a generation. So we're taking out 5 from our farmer's market, 3 from the supermarket, and then the rest from the organic store. And this is the same, I'll just show you, as what we had before, right? We've got 5 from the farmer's market, 3 from the supermarket, and then 4 from the organic store. Not only that, but we can work out the total cost and how many potatoes we bought altogether. And you can see that here with 12, that was our demand. And our total cost is $1.75, just like we worked out before. Now we can actually go one better. This is all very well and good, but we can, if you like, look under the hood of Plexos and compare the formulation of Plexos with what we worked out before. Now, if we go back first to our presentation, the formulation that Plexos gives is found in the same place as the solution file. And just so you can see it, we've got here, this is where our solution came from, and this is the formulation that Plexos produces before finding the answer. So if we double click on that, and what we can do is by bringing this over here, we're going to compare it with what we found or what we had originally. Now, hopefully you can already start to see some similarities with what we've got here and what's in this presentation. But let's just put them side by side. Firstly, let's take a look at it. We've got total cost, and you notice that the numbers out the front are the same. Now there's a plus sign here, but I think we could agree that that's not going to make any difference to whether or not we have a plus sign out here. We've got farmer's market, just like we've got farmer's market over here. Moving down, we can also see that we've got farmer's market and we've got our 12. So again, we've got the same structure as what Plexos just produced. And then finally, our limitations, so our stock limitations. There is, of course, a difference as well. And you might have spotted that over here, rather than having potatoes from, we've got gen load. Gen load stands for generator load, which is another way of saying the generation produced from, which in this case is potatoes. So potatoes produced from, which we could shorten down even further to simply potatoes from. So if we, rather than having gen load, put here potatoes from, and then for each of the different gen loads that we had, we can replace the potatoes from. And you can see that now our first set of equations is exactly the same as what we worked out before. We can do the same thing with our demand requirement, namely that we need to make sure that our total amount of potatoes bought is equal to 12. And then again, we've got a matching between the two equations. And then finally, if we look at the bounds or the limitations, we can do the same thing. And what we end up with is a formulation which matches what we've already worked out. Hopefully this helps you to see that what Plexos is doing, as we mentioned before, really is trying to answer, in this particular setup, where do I get my potatoes from? If you're persuaded with this, you might still be wondering, well, how does this fit in with electricity markets, with power markets? This, family meal scenario seems like a long way from that. In order to get a little bit closer, we're going to have to add an extra layer of complexity. Let's imagine that your fish and chip meals were so successful that someone suggested, you should have your own takeaway. Not only that, but you should make it a 24-hour takeaway. If you were going to do that, you would probably need more potatoes than what you would otherwise be having for your meal. And that being the case, it would open up more options for where you can buy your potatoes from. In this case, we've added a couple of additions to what we had before. Originally, we had these three: the farmer's market, supermarket, and organic store. Now we've got two more. We've got a grow your own option, and we've got a wholesale option. The prices just matching what we had before. So this means 8 cents per potato, and this is 9 cents potato. Our stock limits, again, here we've got 20 and here we've got 80. However, we've added a little bit more complication to each of these two new options. In the first one, we're saying that to grow your own, you actually have a bit of an initial outlay. You need to go buy your seeds, and that means that in addition to the cost per potato, you've also got a cost that you just start with, i.e. this initial outlay. With the wholesale, you've got a 10 potatoes minimum buy, which means you can't buy any less than 10. Hopefully this scenario is okay in your own understanding. You can picture it, where again we're going to make the same assumptions as we had before, which is that the quality is the same no matter which option you pick. And the other assumption, which is that you want as little money going out of your pocket as possible. Hopefully, these two additions have now made it a little bit harder to work it out just in your head. When we first looked at our scenario, we didn't need Plexos to answer the question. We could just work out, okay, farmer's market is cheapest. We'll go there first, then we'll go to the supermarket and then the organic store. With these two additional items, we've got something like a 10 minimum buy. So that's going to affect where we get them from. And we've also got this idea of an initial outlay. So that's going to add to the cost. And so now you can already see how it's a little bit harder to answer this in your head. Now, you could probably work it out with pen and paper, but hopefully you're starting to see why Plexos might be useful if you're starting to get these little subtleties which make finding the answer of the question, where do I get my potatoes from, a little bit harder. The other complexity in this case is that, as we mentioned, it's a 24-hour takeaway, which means that our requirements, as you might expect, will vary throughout the day, right? In this particular case, we've got the demand on the y-axis and then the hour of the day on the x-axis. That's what H stands for. So, the first hour of the day, second hour. And you can, hopefully this makes a bit of sense. You've got, you're going to have, even if you're a 24-hour, you're probably going to have less demand in the early hours of the day. It might pick up towards breakfast and then lunch, You might get a bit of a drop off in the afternoon before dinner is again a peak before dropping off again as the night goes on. One thing to point out is that in our first case, we just had a one-off decision to make, right? We just needed to, this particular meal, where do I get what I need for the fish and chips that I'm about to make? Now I've got to make a decision for every hour of the day. Where should I go for, if I only need this amount? Where should I go if I only need this amount? And what we're going to do is we're going to do the same thing. We're going to go have a look at this particular setup in Plexos. All right, we'll start with our inputs. We've got the two new items, grow your own and wholesale. And we've got some additional columns here. This one's min stable level, which stands for minimum stable level. And we're going to use this to represent the fact that for our wholesale supermarket, where we can only buy 10 or more potatoes. Then for our initial outlay, which was the grow your own option, we've got the 10 cents represented by the start cost. So we're starting out, that's how much it costs simply to start. Finally, rather than home, it's going to be our takeaway shop. And in the takeaway shop, we have the demand for each hour of the day. Remember, the load is just another name for demand. And our hours, as you saw on the graph, are represented here. And the amount is represented here. We mentioned before that there's the drop off. So it goes down low in the early hours, starts to pick up. There's a bit of a drop off in the afternoon before peaking in the evening for dinner, and then again dropping off as it gets a little bit later. Now that we've got it set up, let's take a look at what the results are. Where should we go get our potatoes from? I've hit the enter button on our calculator, if you like, already. And so we have the numbers good to go. Let's start with where are we going to be getting the potatoes from? And here you can see, if we go, it might be easier to see on the chart. Again, if you think of our generation as, how much are we getting from those various markets, you can see the interplay of the various amounts at the various stages. So for example, here you've got taking some from the farmer's market, and then it's hitting its maximum for a little while before it drops off again. And you can look at each of these, right? And then the organic store, which, if you remember, was the most expensive. So generally we don't buy anything from the organic store, but in our peaks we start to buy from them. Not only that, we can also look at some other things. We can look at, for example, how many potatoes do we need for the entire day? And that's here, we're looking at the total amount for the day. So during this particular day, we bought 3,645 potatoes. We can look at, okay, how much did that cost us? And that's shown here. Just be careful that these are now thousands, which means that it's, $398.45 for this particular day. And then one other interesting thing is to look at the prices. So during the day, what were the prices? And this introduces another important concept, which we use in electricity markets. And the idea is fairly simple. You have in your setup let's say we've bought our potatoes. The price or the marginal price, is considered to be the price of the last potato you bought. It might help if we go back to our earlier example where we only had 3 options and the last potato we bought was from the organic store. If you remember, we had to start with the farmer's market, then the supermarket, then the organic store. And the cost of that potato was 20 cents, just to remind you, which means that the marginal price, or the price, is also going to be 20 cents. And that's the price that you see in Plexos, and that's what other people would report in, their day-to-day work. There is also this idea of a shadow price. And the shadow price is how much does your next potato cost? Meaning that if instead of 12 potatoes, what if I was going to buy 13 potatoes? How much is that additional potato going to cost me? That's what we call a shadow price. And often the marginal and the shadow prices will be the same. But for now, you can think of the price, which we can see here. And what you'll see is that because of the fact that we have less potatoes, we're buying it from the stores which have less in stock but are cheaper. Later on, we have to start buying potatoes from the more expensive stores, which means that our cost goes up. All right, if we pause there, again, this should now start to give you a sense of the complicated problems that Plexos can answer for you. When we had our first setup, we only had 3 supermarkets to choose from, and we could do everything in our head because we only needed a one-off and it was all straightforward. Now we've got to make a decision 24 hours a day, and we've got 2 additional options, which means that it suddenly becomes a lot harder to decide where we need to go. And as we've just seen, Plexos can give the answers to that question. It might also be worth just having a look at the formulation to show you that while it's more complicated, the essence of the problem is still the same. If you remember, we had our setup like this, which is, this part was the total cost, and this is what we were trying to, minimize. So we wanted that to be as small as possible. We had to make sure that we met our, potato demand, and then we had the limitations. And in the original formulation, you had gen load rather than potatoes from. So on the left-hand side, you can see that where this is, the left-hand side is just this one here. The right-hand side is the formulation of our takeaway shop problem. Hopefully what you notice is that, oh, look, we've still got the same gen load or potatoes from farmer's market. We've now got this 1 at the end. And if you're wondering what that is, by going down, this should give you a hint. It ends at 24, which means this here is our potatoes from farmer's market in the first hour, then potatoes from farmer's market in the second hour. Similarly, you can go down and we've got our new store, Grow Your Own, right? And that goes for 24 hours. We need to make a decision on how many to get. We can keep going down until we get to the next part of the problem, which, as we see here, is our what they call like a demand balancing constraint. But essentially, this is what we need to make sure we meet, right? We need to make sure that we buy enough to meet the potato demand we have. And you can see that again, when we make the comparison between the 2 problems, we've got the same setup, right? Instead of 12, though, we now have 80. So in the first hour, rather than just buying 12, we actually need 80 for our takeaway shop. We've got the same options as we had before, which was farmers market and organic store and supermarket. However, we can also get them from growing our own or from wholesale. The one, again, just represents the first hour. So in the first hour, we need to meet this demand, i.e. we need to make sure we buy this many. In the second hour, we need to make sure we have this many, 45, and so on and so forth. If we go all the way down, we have some, as we had before, those bounds or those limitations, right? We had a certain amount in stock and it was 5. Now it was adjusted for our particular takeaway shop and the overall bound is now 50, and it's 50 for each of the hours. That's what those 1s and 2s represent. As you can see, while it's certainly gotten more complicated on the right-hand side, the structure of the problem is still the same. We still got the item that we want to minimize, which is the total cost. We've still got to meet our demand, and we still have certain limitations associated with the supermarkets. One final step before making the connection with electricity market. What's happened here is that your takeaway shop has been so successful, you've decided to create a franchise. It's a UK franchise with shops in Glasgow, Edinburgh, Manchester, Newcastle, Birmingham, London, and Cardiff. At each of those, or in each of those cities, you obviously have shops for the various stores. And that's what you can see here. In each of, well, let's just take Newcastle for an example. We have our wholesale Newcastle, that new is just short for Newcastle. Our organic store in Newcastle, grow your own in Newcastle, supermarket, farmers market, Newcastle. Obviously, you could add more stores or you could take away some, but just to keep things still relatively simple, we've just assumed that each of the options that we originally had are available in all the cities that you can see here. Finally, we've added another layer of complexity by connecting up the different cities. And here you can imagine that, well, you don't have to imagine this. There are roads connected to the different cities. And what that means is that maybe it's cheaper to go and buy your potatoes that you need from other cities rather than the options that you have available in London, for example. So in this particular setup, it might be that actually the supermarket in Cardiff is cheaper. So rather than going and buying them from, say, our Birmingham stores, maybe we should go to Cardiff. We're going to ignore for the time being the fact that in real life going along the roads will take time, so we will ignore that fact, but that's what those arrows represent. And so you can, wherever there's a connection, it means you could go that way in order to get your to get what you need. And hopefully that's still not too abstract. You can imagine that this would be the case, that certain places maybe it's easier to grow potatoes, or maybe they're closer to markets, and that means that it's cheaper to go and buy it rather than trying and buying it from what you have in your local stores. On the right hand side, we've added a full week demand now. Rather than having just the 24 hours, we've said, well, actually, a single day of the week might be different. in this case, we might have some in the, the second day of the third day of the week, it might be more expensive. In this particular example, I think the first day is actually a Friday, and then the Saturday is the second peak that you see here, and then you've got Sunday, and then it slowly builds up during the week. But we can check that in Plexos. In any case, hopefully you can see that now it would be really hard, even with a pen and paper, to try and work out where you should get your potatoes from for each of your different takeaways, right? Your Edinburgh's got, and what it's going to cost you in the end. You might still be able to do it with a pen and paper, but it would take a long time. Which means that just as we've done so before, we can put this question to Plexos, and we can ask, all right, during this week that we've got here, provided we've got all our takeaways in these various places, provided we've got all these different shops and options available, provided we can travel or get potatoes from different places without having, or instead of getting them from our own places, where should we get our items from? And you could see that this would be useful, right? If you're a franchise owner, you still want to have as little money coming out of your pocket as possible. So if you can give this question to Plexos and it can spit out useful answers, then you can see why you might need to have such a tool as Plexos to work out this problem. Here it is. We've got our various cities, and we've got each of the different options in each of the different cities. Remembering that our generators are potato generators in this case. We've got a, we have our nodes. This is, if you like, where our actual takeaway is, so that the various cities that are represented here. But we might be interested in questions like, well, okay, what if we divide it up into England, Scotland, and Wales? What are the different prices? How much are we buying for each of those different regions? And if we click, so what we can do is we can group them together, and you've got the 4 English cities here. Scotland's got Edinburgh and Glasgow, and then Wales has got Cardiff. If we want to, just to show you the visualizer or the picture that you saw in the PowerPoint earlier, this is our setup, just as we have before, and with the various takeaways in the various cities and the various options available in each of those different cities. This might be helpful to show you how now you've got so many different options available. I've adjusted the various, maximum capacities. So if you remember, that was just the stock capacity of each of the different items, and then, adjusted the various costs in the different supermarkets in each of the different cities. Once we've hit enter, we can take a look at some of the numbers again. Here, we can look at our price, and it would take a little bit of time to work through all these, but essentially London is the most expensive in this particular setup, and then it goes down from there. So I think Birmingham's second in general, and the price goes up in the same way that our demand changes over the course of the week. And you can see trying to work out these kinds of numbers in or with a pen and paper would be quite hard. We can look at, let's do it this way actually. We have our various cities and we can look at the total amount of potatoes bought in each of those cities. And that's what you see in this chart here. You could even split it up further and look at each of the different stores in each of the different cities to see how many you're getting for each hour of each day of that week that we've shown here. Then lastly, we've got, or we could take a look at the overall regions. Here we're looking at our, okay, how much potatoes being generated for the different cities. But we could also look at the regions, right? We mentioned we've got these divisions in play, England, Scotland, and Wales. We could take a look at, okay, how many, what's the demand for potatoes in England versus the demand for potatoes in Scotland and Wales. And you can see that here, there's a lot more demand in England, then it's followed by Scotland and followed by Wales, with the same pattern throughout the week occurring, right? With Friday and Saturday being the highest and then Sunday being the least before building up over the rest of the other week, over the other days, excuse me. Moving back to the presentation. This should already, you can probably already make the connection with what it looks like for an electricity, market and what people are trying to do. This is a franchise, UK-wide franchise. It's 24/7, the various shops. We have different demands for potatoes over the course of the week, and we want to get it as cheaply as possible. Where do we go? Where do we go and buy our potatoes from? Same question, even though it's much more complicated. And again, just to show you the complexity, we can take a look at the formulation and just make the comparison between what we had before. Here we've got our original setup, the family meal, then our takeaway shop, and then finally our franchise, our UK-wide franchise. However, even though we've got all these additional layers of complexity, the structure and the answer we're trying to get is still the same. We've still got our options available. You can see here. Here, because of the fact that you've got different cities and you've got different prices, that's what that ending is here. The BIR just stands for Birmingham. So your number out the front has changed. Instead of it being 10 cents, it's 15 cents for the farmers market in Birmingham. But as you go down, the structure is still the same. And rather than being 24 hours, meaning you have to make a decision for each of those hours in the day, it's now going up to 168 hours because there are 168 hours during the week and we need to make a decision for each of those hours. And then you could move through down to the next option, which was how many potatoes from the farmers market in Cardiff, and work through. Again, just to emphasize, while there's additional complexity, the structure and the questions that we're asking is still the same. But because of the additional complexity that we've added, Plexos becomes a really helpful tool when trying to find the answer to those questions. If we were to now take a look at what an example UK-wide electricity market model looks like, in going from that switch, hopefully you can see that the general structure has been the same. And in fact, all I've really done is change the names from it being a takeaway to now just being a city. And instead of there being supermarket, this is now a type of electricity generator. And in the same way that we had our various demands for potatoes, now we have demands for electricity. And in fact, there's even a connection you can make between potatoes and electricity. We speak of, when we're eating, we speak of calories. Now, we're probably all familiar with calories, and what does that mean? If something has more calories, it essentially means it has more energy. And electricity could, in fact, because it's, you know, it's a type of energy, could be measured in calories. You could talk about how many calories of electricity you're using. And so while we generally don't, there's even a connection between our potato demand, or our demand for potato energy, as opposed to our demand for electrical energy. Just to round it off, again, the demand here, I've just used the same demand as what we had before. However, the units have changed, and the units we generally use are megawatts rather than potatoes or calories. But the numbers are actually the same in this instance. And again, we've got, 168 hours. We need to make the decision to buy or get electricity for the various cities that we have here. And we want to do it in the same way as what we did when we had the UK-wide franchise. We want to get it. We need to make sure that we, meet all the demand we need. And we want it to be at the cheapest possible price as what we can get. By way of recap, we started with a family meal, and we then moved to a takeaway shop, which went for 24 hours. We then went to a UK franchise, and then we made that connection between our franchise and what you might see in one of our clients' actual Plexos models. And hopefully you can see that while, sure, it got more and more complicated, the idea has remained the same. And the idea remains the same, even in this particular case where we start talking about electricity markets or power markets. One final thing, just to show you that I have also got this in Plexos, this electricity market. And you can see that here. And you could again press enter, and you could work out some of the numbers that you can see here. So you can look at the prices. And because of the fact that I've used exactly the same numbers, the prices, if you recognize, are the same as what we had before in our UK franchise. That's it from me. If you have any questions, feel free to email me. Thank you.